Yeah, first of all, I would like to thank you for the possibility to have us talk today, and thank you for being here. As you see, we are overbooked today. Thank you for that you decided to spend the time listening to me. So I will today actually say a few words about machine learning and how to use it in quality assurance. So I guess there are so many of you, I guess you like buzzwords, right, because of machine learning. Machine learning is a buzzword, and I will show you how to use it, where actually it can be used in quality assurance, and where actually it shouldn't be used. Just a first question: any one of you actually did anything with machine learning before? Okay, cool. Probably that's why so many people here. So first of all, just a few words about myself. I know you had an introduction. I'm actually giving lectures at the University in machine learning. I have a PhD in computer science in machine learning, so this is actually what I'm specializing in. I used to be also a QA, working at IBM and Sabre in the past. And as you see, I'm writing some research papers for Elsevier or Springer. So if you would like to contact me, you have my phone number or email address if you would like to do, or you can actually talk to me in the mind sharing corner after the presentation. So when it comes to the presentation today, I would like to actually show you a tool that we have developed internally at Coletair. There are actually 3 people involved. I'm involved here as the machine learning person. There is also Kuba, who's like our QA engineer, working on that. Also Pavo, who is the project manager. There are also a few developers working on this project on the implementation side. So what I would like to talk about today is I would like to show you an example of one of our customer and the problem that he came to us because he worked before with another company, and he came to us saying, "Okay, please help us because the application doesn't work." Right? So they have developed something for them. It worked for some time, but when they reached some point, the instances on AWS didn't work it well because the application was developed not in the best possible way. I would say the database architecture was designed wrongly, the web page was designed wrongly, and the time actually the queries took so much time that actually the web page wasn't really able to execute in a short time. So actually the app wasn't really possible to be used for commercial. And so the problem is that all of you, or almost all of you, are quality assurance engineers. I guess so. Right? So, it's not the first time actually you did some regression testing, right? So you have developed some regression tests in the past, and it takes time. Obviously, it's easy to do regression testing if we have a green field. It means the project is starting, there is nothing there, just the implementation is starting, the first iteration is just starting, and it's easy to follow. The difficult case, the more difficult case, is when actually as I explained before, when a customer is coming with an application that is working, and you need to handle that, and there are no tests at all. So to rewrite or do the refactoring of the application, you need to have some tests, right? This is something obvious, I think, that you need to have some tests to do it. And it's hard to develop tests for the next couple of months to start the refactoring next. So what we faced a problem that actually the regression testing takes a lot of time, a lot of effort to be developed. And it's true, right? And, the solution here is to do manual testing or develop, actually are 2 only solutions, right? You can do manual testing or develop automated tests. And most of the companies actually decide to do the second option because it's more convenient, you can reuse it, and it's more convenient for the regression test, especially if the apps are complex. So what we have done, we have built a solution that is based on snapshot testing. Anyone knows what snapshot testing is? No, really? Okay, cool. So there's another thing to explain, but I have a video, so it's easy to explain with a video. And we also use some machine learning methods as a support for our testing, for our regression test. So let's take about some numbers. We have implemented it on the 3 live products for now. And before I go to the next numbers, I will show you the video to show you what the snapshot testing is. Here we go. Okay, cool. I'll pause it for a minute. So, what we have done, we have built a crawler that is actually building the sitemap. It's a web application, to be clear. For now, we have just a web application. So we have built a crawler that is actually getting the sitemap just to get all of the pages that are available on the app. So it means all possible pages where actually we can do the test. And here we go. So we just use the crawler. We just put the URL. Unirac is one of our customers that is doing the solar panels in US that we have tested here. And as you see, we are going through all the pages and creating screenshots of each page or part of the page, right? Because sometimes actually you need to scroll down the web page. And we are scrolling down to take all of the pictures. And these pictures are actually the baseline for us. So if you do an assertion, you have the actual, the current state, and the baseline state. As you see here, one test failed, and here you have 4 cases. As you see here, we did it by purpose, just to show you actually how is it failing. There was the logo missing, right, on the top, and this is what what snapshot testing is doing. It's comparing 2 images, the baseline and the current one. And here I have 2 ones. On the left, it's the baseline. On the right, you have the current one, and you see marked by red what's missing. So what's wrong? Where is the bug, right? And if it's fine, it means there is a logo missing because we just prepared the image, the baseline image like that, just to show you the bug. And here on the right is the logo, which is actually the proper behavior. So what we can do, we can actually accept the current state and replace the current image. So what it means, if it's not a bug, we are just not reporting it. If it's a bug, then then we are reporting it, right? And if we are not reporting it, we are fixing it right away, just by clicking the Accept Current button. Obviously, you can turn off the differences here as well. Here we go. Exactly. So you see the difference by red, and obviously the difference can be, it's not about the logo. The page can be, it can be a typo. It can be anything. And actually doing it with Selenium, just going through each element, it's quite difficult to do, right? And now we accepted the current one, and it will be handled then as the proper one. So as the baseline. So we just fixed the test case just in a second. So here is another example where actually we see the baseline is changed, and we see that the tests are passing this time. Again, we are going through the whole web page and doing screenshots. Using Selenium, you need to go through each element, going through the IDE. The difficult thing about that is that I know from my experience that there is a misunderstanding between the developers and the QAs that, let's imagine each of the elements has an IDE that you need to figure out, and it's changing because some developers just change. So you need to agree with the developers to have a naming convention just to have it to keep actually to be able to get the elements on the web page properly. So that's one of the example here. So you can actually run our solution also, because it's not only about the whole tool. It's a library that actually you can use in your Selenium tests. So you can use it directly in your Selenium test, just by adding some new functionality. Yeah, here's another test that we just add, but with the code in a separate Selenium test. So it's easy to implement in some tests that are already working, that are already implemented. Yeah, here we go. So actually changing and maintaining actually the test cases is very, very easy to do. Here's another example of the test of the logo that is here working well. So the tests are passing. I know the UI isn't really perfect, right? It still needs to be we need to make it a bit, the user experience needs to be better. Here you have an example actually of an application, a mobile application that we are testing. In this case, it's just a calculator because we didn't had before any really real-world use case to do that. In this case, we are just testing if 1 + 7 is 8. And as you can see here, we have another project on the list. It's a calculator, and there is one test that is passing. For now, it's passing obviously because we just took the baseline. So, and the second step would be to compare with the current state. So generating test cases is easy because you are just running the crawler, running the tool that is going through the whole app, and generating tests is, it just takes time, obviously, but it's very, very fast comparing to writing each case separately. So here you have the case. Do you see a bug here? Or potential bug? Yeah, the clock, exactly. The clock changed. What else? The battery level. It changed, and it can change, right? Because you're doing the tests, and it can be different depending on the device that you're testing. So, but it didn't find any bug here. Why? Because we set the regions where it should actually skip the testing, like the top. I mean the navigation bar in the top. It shouldn't be it shouldn't be considered to be test because it can change and doesn't really influence anyhow on the app, on the functionality. So that's it for the video. So some numbers. We have 3 live production apps where actually we're using the solution. Yeah, we have even checked how much time actually we are, because working hours costs, right, of QAs, and we check how much time actually we are getting or losing if we use the regular approach, not with snapshot testing and machine learning. So actually, 1 month is enough to get around 80% of coverage when it comes to the functional tests. It's about a month of work because you are actually running the crawler. It's obviously, it doesn't get all of the cases because you have some login forms, you have some forms that are hard to handle in some cases. So 1 month I think it's a proper estimation. And well, 1 QA that is supported by the tool that we have can be equal to about 4 QAs that are doing Selenium tests. I know you heard about machine learning that is replacing the people like the taxi drivers and so on. It will not really happen here because for now I didn't show you anything about machine learning. I mean, for now it's just images. Okay, more numbers. So one of the customers is Language National. It's a language school app where you have 60 languages and 50,000 different landing pages about. So it's a lot of testing, right? So we have 30 million pages to be tested. It's a lot, right? If you multiply it by 10 devices, because we are well, as a device, we are saying, okay, this should be executed with a Firefox, with an Internet Explorer, with Android app, with iOS app, and so on and so on. So it's 30 million pages that need to be tested. So it's not really possible to do the testing manually. Or do you think it's possible? Yeah, maybe all of us here maybe it would be possible to do that. But it's really hard to test so many pages, right? Especially manually. Obviously, you can, when it comes to automated tests, you can somehow generate some scripts that will check some pages and make it more generic, especially if you have the translations that you can take from some XML or JSON file. This is something that you can do. But in many cases, we are not really able to do that. And we did a calculation that actually it will take several months for us to do the testing with our regular QA team, right? And we did it in a month with the solution instead of several months. And what is really one of the biggest advantages of the solution is that we are able to maintain the test cases easily, like I showed you just by clicking OK, accept one of the screenshots. If you have Selenium tests, you need to change the IDs of the elements. You need to add some code again, and so on and so on. So it takes a lot of time. And well, if you have 10,000 tests and 3,000 tests are failing, just an example, then well, you will have about 100 files that you need to update. It's not really an efficient way to do that. So we can compare that actually. For us, it takes a half of a day, 4 working hours, to update all of the test cases, and it can be compared to around 50 Selenium classical automated tests. It's you can imagine how much time actually you are losing in this approach. Okay, so far I explained the snapshot testing. So where actually is machine learning here? I already asked how many of you actually did something with machine learning. Not so many of you. So just to explain what machine learning is. Machine learning is a way of it's our approach how to implement artificial intelligence. Well, there are many ways. Machine learning is one of it. And deep learning is a part of machine learning. It's not something that is separate. It's a part of machine learning because we have shallow methods and deep learning methods, and deep learning are different ones. Actually, they were introduced in 2006, where actually shallow methods are known since, 50s of the previous century, obviously. But what is important here, why I mentioned the buzzword at the beginning. I was on a conference a couple of months ago in Berlin, and we had a booth. Our company had a booth, and at some point, one of the directors of a company from Silicon Valley approached our booth, talking about some business and so on. And at some point, he actually told us a story that one of his customers came to him, saying, "Okay, we need a machine learning solution. Here you have $2 million, and I would like you to implement this solution for us." Okay, so they took the money. They implement the solution, they deploy it to production, they test it, it works. It is working perfectly. But at some point they figure out, well, it is replying to emails, about 50 emails per day. So the director came back to the customer asking, okay, why did you spend so much money to do something that actually someone can do in 1 hour per day and can do it better? Because it's $2 million. And he said, well, yes, that's true. We spent a lot of money, but now we can say that our company is doing artificial intelligence. Right? So sometimes people just do stuff because of buzzwords. And machine learning is a buzzword. IoT is a buzzword. Blockchain is a buzzword. Big data is a buzzword. And machine learning is not something that you can use everywhere. I'm actually quite often in Berlin, where actually many of our customers are placed. And I met many startups or many ideas, people with ideas to become a startup, and they think, some of them think about that if we multiply the buzzwords together, then it will be better financed because we get machine learning, big data, and blockchain together, and it will be a super product that everyone will buy, which is not really true. And why I'm telling that is that machine learning doesn't need to be used everywhere. When I did my PhD, okay, there's one thing. But when I actually came to my customers a couple of years ago, let's say about 5-6 years ago, and said to them, well, guys, you need some machine learning solution here because you will cut your costs or you will get, increase your revenues, they said, no, we don't need it. It's not really interesting. Now, because machine learning became a buzzword and artificial intelligence became a buzzword, everyone wants to do it. Everyone wants to do something with machine learning. Everyone wants to implement some AI. And even companies that didn't really had anything to do with AI before, they now call themselves AI-based solution doing something. And the case here is that the thing is that not every solution really needs machine learning. So, because most of you that doesn't really have experience with machine learning, it works in the two phases. I mean, there are more phases here, but there are two major ones. It's the training and the prediction phase. The training phase is where actually you are building the model, the machine learning model. When we say neural networks, which is the most popular machine learning methods, actually the training is just you have a huge matrix, weight matrix, with some numbers inside, and the training is only about putting some numbers in this matrix. Because at the end you have a mathematical function that is executed for the prediction. The label here, what can be the label? Okay, I did my PhD in skin cancer diagnosis. So if you take a picture of your mole, the label is it's a cancer or not. When it comes to the features, it can be what size it is, what color it is, and so on. You can obviously move it also to the QA, like what's the resolution of the image, what browser is used, and so on and so on. But as we have 30 million of pages, we can also use some deep learning methods where actually you can put just raw data. You know Google Photos, right? Most of you know or use it in the past. So let's type dog or cat into your albums, and you will figure out that it will show you the images where the dog is on it, even if there was there's no description that it's a dog inside. Why? Because it is using convolutional neural networks, usually some transfer learning, just to detect the objects instead of the description. So it doesn't use the labels, it doesn't use the description, and this is how actually we can use also for QA. So one of the use cases where actually we are using machine learning is also detecting objects. The case that I have explained before is when the IDs of the web page are changing, the elements are changing, the names of the elements are changing. So here we're actually detecting that the item is an image, or it's a button, or it's a link, and so on and so on. And it's easier to do it this way rather than going through the HTML and figure out the exact element on the web page. So this is one of the use cases. Another use case. What's wrong here? This is just some screenshot from one of the famous e-commerce in Poland. What's wrong here? But it's a bug. Is it a bug? Do you think it's a bug, or this is something that we should report? Not really, because we have dynamic content here, right? So we have a content that's changing very often, like the phones, right? But what is important here, that the template doesn't change, right? And we can test using machine learning methods the template. So if the layout is the same, because this is important for us, not really the content. Obviously, the content is the other thing, because we would like to get to know if this is a phone on the image. Is this a phone on the image? But the other thing is that we would like to think about the template. And you have a button here, template. And there are different ways of comparison of the templates here. One is actually if we have columns, how many columns we have, and so on. The other thing here, something that I already mentioned, the case with the clock and with the battery, because this is something that can change. This is something that can change when you do some testing on mobile phones, for example, right? So this is something that we can also just say, okay, just skip this part of the image. And another thing is that we can actually generate based on the test cases on the crawlers that we use, Selenium tests. So we generate code based on the previous examples. So that is also something that can be used. Here are just a few examples because to be honest, we are still working on this part. But this is something that, can be used easily because we would like to then move to some code, especially if there are some test cases that really need to be totally custom and it doesn't really has it's not really related to the image totally. Okay, almost running out of time. What we are still working on, first of all, is the UI. Because for now, as you see, it's just not too much. It doesn't look pretty. The second thing, I don't know if you know Cloud Vision, Google Cloud Vision. We would like to integrate it with Google Cloud Vision API. You saw the example with the phone here, right? Obviously, the good thing is that we can train based on our images and train it based on that, train to what kind of objects we have on our web page. But in many cases, we will not have enough images to train our model because training model is not that we just put 2 images. We need to have, 100 or 1,000 of images. They're more than better. And we have already something like that. It's Google Cloud Vision where actually we put the image and we get to know what's inside, what's in the image. So let's imagine you need to check if you need to check some video page, let's say YouTube, right? And you need to check if there is a dog in this video because this is your test case. Just abstract case. And using Google Cloud Vision, you are able to do that because you're just putting the video link there, and you get the information what's on the video or the image, right? With the image is a bit easier, with the video a bit more complex. But this is something that we can do, and this is something that we are currently working on. The other thing is that to test data sets and to generate test data sets, from ISTQB that you have the case when you are using too often the same data sets for testing, then the test became, they doesn't really test too much at the end. So we would like to use our machine learning methods to generate some test cases, test data sets that will, every time will be different. It's not so easy to do at the end. We also would like to do a better handling of the logging and regression form. For now, we just fix the data, but it can be done in a more sophisticated way, and this is something that we are also currently working on. Yeah. Also, we would like to add some native apps. So I know today there are not so many native apps used. So usually we have web or mobile apps, but still we would like to add a support for that. And also iOS, which is not really so difficult because we have already Appium. We have integrated with Appium, so it should go quite easy to actually add also the iOS support for that. Okay, I'm almost running out of time. So just to finish, I'm also a O'Reilly trainer, so please find me at Safari. I know it's not related to QA. It's about machine learning and chatbots. If you would like to know more about that, find me at Safari. And and if you have any questions, it's a good time to ask questions, or in the mind sharing area, right? Yeah. So, thank you.
Thank you very much, Karol. Thank you very much. So now we have a few questions from our audience. The first question.
What could happen when machine learning
learn
too much? Okay, let's go from what? No.
Yes, go on.
why machine learning and Python is the happy combo? Yeah, it's a good question. I just had 2 weeks ago, I had a presentation about machine learning and JavaScript. 3 months ago, I had a presentation about machine learning and Ruby. And why Ruby and JavaScript is not so commonly used in machine learning. To be honest, I'm not really sure about it, but I'm sure about one thing. If you take a look on Python and the libraries that you have available for Python, for machine learning, well, currently is the leading language when it comes to the support for machine learning. You have Scikit, you have TensorFlow, you have Keras, you have PyTorch, you have PySpark, and many, many others. Obviously, you can do TensorFlow in JavaScript because there is a fork of TensorFlow for JavaScript. But still, Python is the leading language. So just the scientists decided to go into this direction. They have decided to implement the methods and there are so many libraries. That's why it's so popular.
Thank you. And the second question?
But we are doing it with Java. What could happen when machine learning learn too much? Is it possible? Will be
different?
Yes, you can overfit. You can overfit each model. There is a thing. Well, to describe it better. To get a good model, you need to generalize well. Generalizing of a machine learning model, you have a mathematical function that, let's say, it looks like that, right? And the goal is to go to the goal is to find the minimum of this function. So go somewhere here on the bottom. But sometimes it can go also up because you're overfitting. So it means it's working well just for some special. I mean, for the training data set. Yes, this is a bad thing that can happen. That's true. So you need to think about it when you are learning your machine learning models. Will be our people manual testing needed? It depends. If you take care about overfitting, obviously if you don't do retraining, right, then there's nothing really to do. If you do retraining, you can still overfit. Obviously, if you didn't check it before. So maybe, but it depends how good you are at machine learning.
Thank you, Karol. We don't have more time, so thank you very much for your very interesting presentation.
For the rest of the questions and answers,
yes.
Please meet me at.
Of course, you have still chance to ask even more questions to Karol in our newsrooms number 11. So thank you very much, Karol.
Thank you.
Thank you very much. Big applause for our superstar, Karol Przystalski.